Hello everyone. First of all, thanks to Emerging Information Technologies for giving such a wonderful opportunities to do our internship program in embedded system. The project which we have done in this internship is microcontroller based washing machine simulation using PICSIM lab. This project was done by Namagal and Pravina from the College of Ishwar Engineering College. Embedded system. Embedded system is nothing but it is a combination of hardware and software designed for a specific function. An embedded system is a microcontroller or a microprocessor based system which is designed to perform a specific task. Some of the real-time examples are smartwatches, home automation system, medical devices, etc. Embedded C. Embedded C is nothing but it is a programming language that is used in the development of embedded system. Embedded system are specialized system designed to perform very specific functions or tasks. Embedded C requires less number of resources to execute in comparison with the high-level languages such as assembly programming languages.
Microcontroller. A microcontroller or microcontroller unit is a small computer on a single integrated circuit. A microcontroller contains one or more CPU along with its memory and programmable input-output peripherals. It is usually used for application-specific purpose, and also it should be divided into three types of microcontroller. One should be the 8-bit, another 16-bit and 32-bit microcontroller. Microprocessor. Microprocessor is a computer processor for which the data processing logic and control is included on a single integrated circuit or a small number of ICs. The microprocessor contains the arithmetic, logic and control circuitry required to perform the functions of a computer CPU. Microprocessor contains both combinational logic and sequential logic. And goal of our internship is to develop a comprehensive simulation of a washing machine using a PICSIM lab with the aim of replicating a real-world washing machine functionality within a virtual environment. This involves the gaining a in-depth understanding of washing machine components, cycles and operations, as well as the identifying the parameter that define the laundry status such as fabric type, load size and water level. Through this internship, the goal is to provide the valuable insight into the washing machine operation and control system design and simulating technique, and in turn will gain practical experience in applying the algorithm to stimulate the intelligent applications, thereby contributing to a deeper understanding of laundry automation.
Project requirements. What are the components required for the projects are power on screen, washing program screen, water level screen, start screen, function screen and completion status screen. Power on screen. The first requirement is power on screen. Switch 5 is used to power on washing machine. When we press the switch 5, it will print powering on washing machine on the display, and this is the first step for this program. Washing program screen. For washing program screen, we need to press the switch 5. The washing program menu that contains options such as daily, heavy, delicates, white, stain wash, eco cottons, woolens, bedsheet, resign press dry, dry, dry only, wash only, aqua store, etc. We can also scroll between the option by pressing the switch 4. If we long press the switch 4, it will select the option which is highlighted.
Water level screen. This screen should allow the users to select the water level. The water level menu will contain the following display like auto, low, medium, high or low. By using the switch 4, we can able to scroll between the option available there. It must be auto, low or medium. A long press of switch 4 will select the option highlighted. Start screen. Once the washing program and water level is selected, the CLCD should display the start and stop option. We can access the start and stop option through the switch 5 and switch 6. While pressing the switch 5, it will start the machine and display the function selected and time taken, then switch to the function screen. And while pressing the switch 6, it will stop the machine and go back to the washing program screen. Function screen. Once the machine started, display the functions ongoing. It can be wash, rinse or spin. Along with the display, the time left on the CLCD should be displayed. And while switch 5 is pressed, the washing machine start, and switch 5 is pressed, the washing machine can able to pause. The status of switch 1 here indicate the door status. While the switch 1 is pressed, it indicates that the door is open. When the switch 1 is not pressed, it indicates that the door is closed. Completion status screen. Once all the program are completed, then the notification should be program completed. Remove cloths on the CLCD display.
PIC 16 F877A is a microcontroller is used in this project. A PIC 16 F887A is a 8-bit CMOS flash-based microcontroller. It has 4 ports, namely port A, port B, port C, port D and port E. It supports serial communication for which it has 2 pins, transmission and the receiver. It contains data memory up to 256 byte. It is based on modified hardware architecture featuring both program memory and data memory spaces. Block diagram. This block diagram shows the functional requirements where we make use of 4 switches only. Switch 5 is used for power on. Switch 6 is used for pass or stop. Switch 4 is used for navigation. Navigation is nothing but that is used to navigate the options such as water level or mode of washing. And switch 1 is used for door status in case the door is open between the operations. The buzzer that produces a sound when the program or task as done, and CLCD screen display the status of the washing machine, and motor runs only when the washing is in closes or open. That shows that is working properly or not. Light emitting diode. This LED is a output device. It is interfaced with microcontroller in 2 ways. One is sourcing and another one is syncing. In sourcing circuit, when the pin is 1, it is connected to the VDD, and when the pin is 0, it is connected to the ground. In syncing circuit, when the pin is 1, the LED is in off condition, and when the pin is 0, the LED in on condition. In PIC 16 F877A, port B and port D contains LEDs. Because port B and port D are 8-bit, they contain 8 LEDs. They are programmed by the data direction register called TRISP. If the TRISP is equal to 0, the port B will act as an input. If the TRISP is equal to 0, the port B will act as, if TRISP is equal to 0, the port B will act as a output. If the TRISP is equal to 1, port B will act as a input.
Switches. Here we use the tactile switches. Tactile switches is nothing. It is a one type of widely used switch that completes an electrical circuit typically when pressure is applied to the device by the user, when the giver which then gives the users a perceptible click or haptic bump in the response indicating the current flow. And also interfaced with the microcontroller for detection of switch press, we use two type of switches. One should be the pull-up circuit, another should be the pull-down circuit. In pull-up circuit, the pin should be 0. If the pin should be in 0, then the switch should be pressed. If pin is 1, then it should be released. In pull down circuit, if the pin is in the 0th condition, then the switch is released. If it is 1, then the switch is pressed. 2 types of detection: level triggering and edge triggering. Level triggering is based on to trigger based on the value. For example, in volume button, the value should be changed continuously. The action should be changed in continuously. In edge triggering, the trigger that should be based on change in value. For example, power button, it should be the one-time access method. And also in our microcontroller, we use the
Interrupts. An interrupt is used for an internal or external device request the microcontroller to stop the processing. The microcontroller unit acknowledges the request, attends to the request, goes back to processing where it is interrupted. Interrupts are 2 types. One is hardware and software. In hardware, it is again divided into 2 types. One is non-maskable and maskable. In maskable, there are 2 types, external and internal. Interrupt vector table is nothing but it is a one kind of directory where all the information about the interrupt is stored. Interrupt request routine is a special function that like a quick response team for interrupt. When an interrupt happens, the computer calls this function to deal with it. Interrupt latency is nothing but it is a delay in the execution of the interrupt service routine. In the interrupt service routine will not be executed as soon as interrupt is requested delay. Complete the current one or the PC. It will complete the current processor. Interrupt flag. Interrupt flag is a signal that tells the CPU an interrupt is pending. When an interrupt is requested, this flag gets set. Interrupt service routine execution. Once the CPU finishes what it is doing, it checks the interrupt flag. If it is set, it known as interrupt needs attention. So it is called the interrupt service routine to deal with it. Clearing the interrupt flag. Once the interrupt is finished, it will clear all the interrupt flag.
Timers. A timer in a microcontroller is a peripheral component that generates a timing signal or count. And resolution is nothing but it is the width of the timer. Example 8-bit. And also tick. There are two ticks. Up tick, one should be the down tick. Here quantum is the time taken for a one tick. One tick takes 4 clock pulse and it is calculated by the clock frequency. And overflow is nothing but when the maximum count of the timer register is reached, it is a overflow. And here the time taken by one overflow should be calculated by in the timer 8-bit the value should be between 0 to 255. It means totally 256 value. By multiplying this with 200 nanosecond we can able to get 51.2 nanosecond. And also the time taken to count the overflow should be time is equal to count asterisk time taken for one overflow. By multiplying this value we can able to get the time taken for count overflow. Scaling. Scaling is a technique used to adjust the time taken to trigger an interrupt service routine. There are the two types of scaling. One should be the pre-scaling, another should be the post-scaling. In pre-scaling, dividing the clock input to the timer by a specified factor. In post-scaling, adjusting the time between the timer overflow. And interrupt controls. There are two interrupt control here, GIE, another should be the PEIE. And GIE is nothing but Global Interrupt Enable. It will enable all the unmasked interrupt globally. And Peripheral Interrupt Enable is a PEIE. It will enable all the unmasked peripheral interrupts. And here we use the register configuration is T2CON. T2CON is nothing but timer to control register. It should be used for configuring the timer to setting. And PR2. Period register 2 is a specific after many ticks the overflow should occur.
Colors LCD controller. It is a variant of LCD. A 4x16 variant is used in this project. If the register status is equal to 1, it will be data. If it is 0, it will be instruction. If the enable is 1, it will enable the CLCD. If enable is 0, it will disable the CLCD. The data lines ranges from D7 to D0. Each instruction will take some time and we have to provide some delay also. Buzzer. Buzzer is nothing but it is an electronic device that make noise when electricity flows through it. Commonly used for alert and notification in different devices. And RC1 pin is nothing but it is a specific pin in microcontroller that can be used to control external devices. It allows us to send electrical signals to connected components. In our case, we will use to turn the buzzer on or off. And we will also add some delay. We will also add some delay. We need to make the buzzer noise after a certain delay. Fan. Fan is nothing but it is used to indicate that the washing machine is in on condition or off condition. RC2 is used to turn on or off the fan.
These are the tools we used for our project while in internship. The tools are PiximLab, MPLab Cross IDE, XE8 compiler. PiximLab. PiximLab serves as a real-time emulator for the development board and offering a seamless integration with MPLab Cross IDE. It provides an environment for simulation and testing of embedded design, supporting a microcontroller from the PIC and AVR families. With PiximLab, we can emulate hardware behavior, test our code, and debug our project without needing an physical hardware. And In MP Lab Cross IDE is a comprehensive development environment equipped with powerful tools for microcontroller development, and it have the features like data visualize, IO view, helpful design resource, and it should be easy to use. And also the IO view enable the monitoring and controlling the input output port, facilitating the hardware testing. And this will provide the helpful design resource and documentation, making it easy for developers to navigate and utilize. And MPLAB XC8 compiler. This compiler is optimized for 8-bit PIC and AVR microcontroller, and it is efficiently convert the C code into high assembly language instruction tailored for this microcontroller. With the MPLAB XC8 compiler, developers can ensure the optimized performance and resource utilization for their embedded applications.
Now we are going to see our project, and this is the Pixim lab. In this Pixim lab, we use the microcontroller PIC16F877A, and this is the LCD screen which display what are the necessary item are there, and these are the switches, and the respective LEDs are connected to the switches, and this is the buzzer which indicates which produce the sound after the washing program is over, or when the door status is open between. And these are the switches for the respective actions. And now we are gonna to implement the program. If we press the R4, it will select the washing programs. If we long press the RB3, it will select the water level for that program. Just wait a minute. Okay, now the water level for the program is selected. Now again we will select the RB4. Now again long press the RB3. Okay. Okay. Now the press switch is displayed in the CLC display. Yeah, by pressing the RB4, it will start the process, and the time will display in the CLCD display. Now the fan will rotate. Once the time is over, the fan will stops the rotating. And we can also pass the process by selecting the RB5 pin. Okay, the program is now over. In that CLC display, program is completed and the cards are ready to taken will be displayed, and the buzzer will produce a sound. And okay, this sound indicates that the program is over. Now the cards are ready to taken from the machine. These are the codes we used for our project, and at the end of our project, we learned the Pixim Lab washing machine simulation was like a practical playground for learning about the embedded system. It helps us understand complex idea by letting on our hands. This experience was not about just about theory. It opened door for us to explore more about many things, work automatically. It's like having the right tools to solve real life problems in the world of technology. Okay, thanks for MSG for giving such an wonderful opportunities to gain our knowledge in embedded system. Thank you.